Okay, so here, I've alluded to this before, but suppose the remainder is 0. What happens if the remainder is 0? We know what happens if it's not 0. We would say whatever we would plug in, if we're trying a root, if we plugged in k, whatever would be the remainder would be what we get if we plugged in k. That may not sound feasible, but if I say f of, it's always the opposite sign. Why would I say 4? K, f of k, that would be my remainder. And in this case, it's 0. And I say, well, what happens if it's 0? Well, if it's 0, what we're saying is that that's a root. We found a 0. Okay, so let's look down here. It'll be easier to see down here. We say x plus 2 is a factor. So we use minus 2 because minus 2 goes with plus 2 to make 0. And we get a 0. Okay, we don't get, if we got like 5, we'd say f of minus 2, we'd say f of minus 2 would give us 5. We'd know what would happen if we plugged in. Well, in this situation, it's not 5, it's 0. So we'd say, well, so that means that that's a nice root or 0, okay? And we're going to make it our business to find those. So if we were trying -2 and we got 0, we'd be very happy because then our trial and error would be over. We would have found something. So let's go ahead. And here, as I was talking about in the last video, we're given a factor. We're told that x plus 4 is a factor. So we're going to go ahead and solve this we're going to use the information. We're going to say x is equal to minus 4. And we say minus 4. And we're going to use synthetic division. So we say I have 1. I have 6. Here's 1. Here's 6. Here's 5. -12. And I draw a line with some room in between. And I say, okay, the 1 comes down. Now I say -4 times 1. -4 times 1 is -4. I put it right there and I add. Okay? And when I add, I get a 2. And then I say -4 times 2. -4 times 2 is -8. And I add. And I get -3. Then I say -4 times -3. And I get positive 12. And when I add this, oh boy, I get a 0. So, that confirms what they told me. I mean, I believed them. But it does confirm since I get a 0. And it also tells me something else. First of all, I have x plus 4. That's what I just divided by. And then I also have this 1 out in front. So it used to be x to the third. Yeah, well, now it's x squared. And I have this plus 2 here. I guess I don't really need to write that plus 2. You know it's a plus 2. Plus 2x. And then I have this minus 3 that I'm going to use as my constant. Okay? So I just factored this a little bit. I took the x plus 4 out of this bigger polynomial. Okay? And now let's see, can I factor it any more? That's always the question. A little greedy here. It's not bad to be greedy here in this situation. We want to factor it completely. And we can. We can say x plus 3 and x minus 3. If you want to use the ACB method, you can, but I think you can just spot that. You can see that if I multiply, x times x is x squared, x times minus 1, and x times 3, that's going to result in 2x, right? And then 3 times minus 1, that's minus 3. So there it is, and it's all factored. So the synthetic division helps me get rid of that x to the third. And then I just noticed that I can keep going on that last part.